Hi guys, I showed you many times in my previous video how well this homemade CNC machine worked. I started building this machine with a lot of cheap components and materials like the MDF board that I have for the brackets and the Leadscrew and everything. And for the spindle, I started with a wood router that was really loud. So I did a spindle upgrade with a water-cooled spindle and it works a lot better now. But there's still a lot of room for improvement. For example, the Leadscrew and also all the brackets here, they are made of MDF board. So I can upgrade them to like steel or aluminum so they will be more sturdy and that will improve the precision of the machine. So today I will continue the process of improving this machine. And the first thing that I will change today will be the Leadscrew. I will replace them with the Ballscrew SFU 1204. The reason that I want to replace the Leadscrew with the Ballscrew, even the Ballscrew are louder, but they can work smoother and they don't have the gap that you can see or feel. If you try to push the axis like this, you will feel that there's a gap just pushing back and forth. That gap will be fine if you mill something soft like plywood or plastic, but when you mill something hard like aluminum like this, the part not going to be milled the same way when the spindle moves this way or this way, because the spring will be pushed differently and the gap can be compressed or extend depending on the direction of the spindle. So that's why I choose to upgrade the Leadscrew to the Ballscrew. And I bought 4 Ballscrew for all the axes. 3 of them are 550mm length and the one for the Z-axis is 250mm length. They are end machined. This end of the Ballscrew is machined to 8mm bearing and this end is to 10mm bearing. So they have like specific length and also specific bearings to support the both end. First of all, I will have to make the bearing blocks like this or that to support the end of the Ballscrew. To make them really sturdy, I will make them with aluminum. But if you just start building this machine using your 3018 CNC, you can mill the pieces out of plywood and replace them with aluminum later once you are done building the machine. So let me just start milling some pieces and I will show you how I put the bearing blocks together. As you can see, for the thick piece of aluminum, I really did a very shallow 2D contour at the end just to mark the outline here. And then I will use my miter saw to cut the pieces out following the outline. That will be a lot faster and more efficient. Next step, I'm just going to cut the pieces out using my miter saw. It's really just like you cut wood. Just make sure that you clamp the pieces down really like tightly so they don't fly around when the machine is cutting them. And make sure that also when you adjust the blade, the edge of the blade here will follow roughly the line here. You don't need to be exact, but try your best. Cutting the aluminum pieces, I always wear my safety equipment like the face shield, long sleeve shirt. When cutting with this saw, the aluminum chips will fly around and they might hurt you if you don't wear those equipments. This piece seems to be a bit too high and it blocked this part of the saw, so I will have to flip this over and cut it. As you can see that the cuts are not really precise and also not really smooth, but that wouldn't be fun. The only thing that need to be precise are the position and the size of the holes. The outline here, you can just cut them roughly, so this will save a lot of time. I was testing the 2D contour toolpath on this thin piece of aluminum just to see how fast I can go, and the cutting speed was really acceptable. The feed rate was 600 mm per minute and the plunge rate was 1.3 mm. So this machine cut aluminum as fast as the 3018 CNC cut plywood. I think that I will use 2D contour to cut out the next pieces. That way the pieces will look a lot better. I have all the pieces needed for the bearing block cut or milled out here. You will have 4 of the pieces that are thick and with the bigger hole like this, about 6.5 mm, and 8 of them with smaller hole right here, about 4.8 or 5 mm. I will have to make the M6 thread into those holes, so I'm just going to use the M6 tab to make the thread, and I will show you very soon in the next step. And the other thin pieces that you will need to put together the bearing blocks or to fix them on the machine. On most of the thin pieces, you will see the notches like this. You will need to bend the piece at the notches like this, like 90 degrees. I will show you how I do this after I make the thread on those thick pieces. To make the thread, I'm going to use the M6 tab and put on some cutting fluid. And that's it. I only need to do the same for all the other pieces. Now to the thin pieces that have the notches on both sides, you just need a vise like this and clamp the piece down at the notch. And then you can use a hammer to bend it 90 degrees. The piece might not bend exactly at 90 degrees, but you can correct it and make it as close as 90 degrees as possible. And that's it for these pieces. I'm done bending all the pieces. Now let me show you how I put the bearing blocks together and start installing them on the ball screws. You will need 8 of these bearings, 10 by 26 by 8 mm. So the inner diameter is 10 mm, the outer diameter is 26, and the height here is 8 mm. And 4 of these bearings, 8 by 16 by 5 mm. For the big bearings, you will need 2 of these blocks, one with the 2 holes that are threaded, one with the 2 big holes here that are not threaded. So we just put the bearing in here like this, and later on you will stack them up together like this and use the M6 bolt to tighten them together. One thing that I did wrong here, and you can see that the bearing can slide out right away, so the holes were too small, so I correct it. I milled it a bit bigger and I milled it too big. So now to prevent the bearing from moving inside this slot, I will have to drill a hole here, make a M4 thread, and use a set screw to fix the bearing inside here so it doesn't move around in the slot. I will drill some holes on the side of the blocks with a 3 mm drill bit, and then I will make a M4 thread, and then I can use a M4 set screw. Okay, so I have the hole just threaded here. So what I do is just I'm going to slide the bearing in here like this, and use the M4 set screw. Just put it in the hole and just tighten it on both sides. That's it. Now the bearing not going to go anywhere. For those smaller bearings, you just take one of those thick blocks that have smaller holes in the middle here. Put the bearing inside like this. Take one of the U-shaped piece like this. Put it on here and put them together using some of the M6 bolt. For these bearing blocks, you can fix the pieces together right away. Though bearing blocks, they might not look very precise, but I will show you that it's not a big problem because I know that my machine right now doesn't mill aluminum that well. So the way I designed the new machine, just I leave a lot of room to play with. You won't be able to move those pieces around and play with their position. In the end, the most important thing is how tightly you bolt all the pieces together, and the precision of the machine will depend on the sturdiness of the frame. You will make 3 of these. And for the fourth bearing block, instead of taking the U-shaped piece like this, you will use this flat piece, just doesn't have the flange. You put it on here. And then take this piece with the big slot here, stack it on this, and tighten all the pieces together using 2 M6 bolts. And you don't need to tighten it too tight right now, just leave it a lot of room to move around. And later on you will need to adjust the position of these bearing blocks depending on the position of your ball screw. To install the bearing blocks on the ball screw, I will need some more things. First of all, I will need 8 of the M10 nuts, 1 mm pitch, and also a few of the M10 spacer. I will make them myself, but you can also buy them anywhere like Amazon, AliExpress, eBay, anywhere. For the M10 nuts, I will use the M8 nuts, and I will bore it out using the 8 mm drill bit. After making the hole bigger to 9 mm, I'm just going to use the M10 tap 1 mm pitch to make the thread. I already tested the nuts on the ball screw and it fits perfectly. And for the spacer, I also need 8, so I'm just going to use the 10 mm drill bit to bore out the M8 nuts. Actually, the M8 nut is really small, so I'm just going to use the M10 nut. Just make sure that you put enough cutting fluid so the bit doesn't get stuck. This time I'm really ready to put the ball screw setup together. I have the 4 ball screw here with all the pieces that I need to put together. First of all, for the end bearing block, just have the 8mm bearing. You don't need to install them right now. You will install them when you actually put the machine together. So you just put them aside. Now just take one of the ball screw. Then you take a piece of the bearing block that have the 10mm bearing on it. And also the two holes here are threaded. So you just slide them in here like this. Remember that the face that have the bearing here just face out. And then take the other piece with the holes that are not threaded. Clamp them together like this. And then take two of the 10mm spacer and slide them in here. Okay, just push them all the way down. And the reason that I need two of them because I want the height of this go into the thread port. So later on when I tighten the nut, you can push the spacer down into the top of the bearings. Now just take two of the N10 nut, 1mm pitch, and just like tighten them in here. I'm just going to tighten the first one first, like push it all the way down. When you tighten the nut and you don't feel any type of play this way, like when you push it back and forth, you can install the other nuts on here and jam lock them together. Once you jam lock the two nuts together, they will never get loose. That way everything will stay tight. And on this side of the bolt nuts, you just take one of these spacer, put it here. I had to roll it out a little bit. Just be careful, never roll this ball nuts all the way out without having a plastic tube to keep the ball bearing inside here in place. If not, the ball bearing will fall out and it is almost impossible to put them back. Then you take one of the nut housing, just slide them in here. The reason that I need the spacer is because I have the grease nut here. If I don't have the spacer, it will block the edge of the nut housing and it's not going to lay flat against this piece. And now we need 6 of the M4 bolt, 15mm length, but I don't have 15mm length, I only have 20mm, so I will have to put some spacer in here before I fix the bolt. I will use some of the M5 nuts as spacer. And that's it, you only need to do the same for all the other ball screws. I have all the ball screws set up, put together. Now they are ready to be installed on the machine. But because of the different insides between the ball screw setup and the Leadscrew setup, I will need new brackets and plates to install them on. I can always do the same as before, is to make the brackets and plate out of MDF or plywood. But I want the new machine to be really sturdy and it can mill aluminum very precisely. Even milling steel, I will test that in the future once I am done putting the new machine together. So instead of MDF or plywood, I will try to mill the new pieces out of aluminum 3x8 of an inch thickness, so about 9.5 or 9.6mm. That I think will be sturdy enough. And also, as I told you before, I will try to cut the piece out using the 2D contour, even though it will take a bit longer compared to cutting with the saw, but I think it will look a lot better. So let me just show you a little bit the process of milling those pieces. I got a problem here that the bit broke in the middle of the tool path. The reason is that the cutting track is really narrow and deep, so the chip cannot clear out even I try to vacuum it. And then after a few passes it got stuck on the bit and then it broke the bit. So now what I'm going to do is just I'm going to use bigger bit for the 2D contour first so I can clear out the chips. And then afterward I'm going to use the small bit again. For the first round 2D contour I'm going to use 2 flute 6mm flat end mill. My plan didn't work, the chip still got stuck to the bit and the machine was rumbling. So for this piece I will have to use my saw to cut it out. And for the future I think that I will have to do the adaptive clearing for the contour first. And then the last layer I will use the 2D contour to cut it out. I will try one more time to cut the piece out using the CNC machine. This time I will use the adaptive clearing toolpath to cut along the outline of the piece, and I will leave at the bottom a layer about 1.5mm, and then I will cut the piece out using the 2D contour toolpath. I wanted to see how long it's going to take to mill this small piece out, and then I will see what I should do with the bigger pieces. As you can see that the piece will cut almost perfectly until the end. When the 2D contour tool pass have a lot of loading, just push the piece a little bit, just move it away. Luckily the bit didn't break, but in overall everything will cut beautifully. And on the side here the finish was really nice. You almost have the mirror effect with the 2D contour. One thing that I have to say about the adaptive clearing tool pass is that it is really slow, and it took me about 1 hour and a half to mill this piece out. So to mill the big piece like the back of the Z-axis block, it's going to take like hours. I don't know how many hours, but I'm not going to do that because I don't want to spend whole day just standing here and vacuum the chips. So what I will do with the big pieces is that I will cut the stock to size using my saw, and then I only mill the details inside the piece. That will be a lot faster. So let me just mill the rest of the brackets. I'm almost done milling all the big pieces, like the back of the Z-axis block here, like the motor mount for the X-axis, the gantry plate and everything. There's still 6 brackets left, the 4 at the corner of the frame here, and 2 big ones on the side of the X-axis. The pieces, I want them to be thicker, more sturdy, because these 4 pieces will take the whole weight of the machine standing on them. And these 2 pieces are really big. and also had to be very sturdy to stand the force when cutting this way and this way. But my machine start to get loose. I can feel the gap a lot more in both axes like X and Y, and also the Z axis become a lot more flexible, so it doesn't mill very precisely at the end. So what I will do is that I will mill those 6 pieces out of plywood so I can install the ball screw on X, Y and Z axis, and on the Z axis I will have everything made out of aluminum, so this will be very sturdy. That way I can mill the next pieces more precisely. It turned out that I am out of plywood, so I'm just going to use MDF. MDF is not as good as plywood, but it will be okay because I only use the brackets for a very short time before I change them to aluminum. Now I'm going to mill the 2 big plates for the x-axis, and the way I'm trying to set this up is a practice for me before I mill the piece out of aluminum, because the aluminum stock that I bought is kind of expensive, and also that the dimension of the aluminum plate fit exactly the 2 plates for the x-axis, so I don't have room for mistake. As you can see, I try to fit these two big plates in one piece of stock, and there's this part overlap between the two pieces. So this way I will save a little bit on the length of the stock, and this will be exactly the way that I will use to mill the two pieces out of aluminum. And another thing that you can notice that I use the two screws here to fix the stock down into the wasteboard instead of using the clamp or bolt, because this piece of stock is as wide as my working area and the same with the length of the piece. So I use the full working area, so I don't have any space to clamp it down using the bolt. And of course I had to put the screw at the area that is not milled, like in the middle of the board down here. To mill aluminum, I will have to put more screw like around here, so the piece will be fixed down tightly and it doesn't move when milling. Now all the pieces are milled, I'm ready to replace the Leadscrew with the Ballscrews. I will start by disassemble the Z-axis block, because I will have to replace almost everything on here except the rails, spindle and stepper motors. Everything else will be replaced with aluminum plate. And I also will start to untighten all the wires so I can put all the components aside. Then I will have more space to work on the frame of the machine. All the Leadscrew setup are off the machine and ready to be sold on eBay. I just uninstalled all the stepper motors. So now I will start to install all the brackets. I will start by replacing those two big plates on the x-axis, and then I will install the x-axis on the rails. That way I can test and make sure that the whole setup can still move back and forth smoothly when I replace the bracket at the corners of the frame. For the same reason, before tightening these two plates, I will install the back of the Z-axis block on these two rails just to make sure that it can move back and forth smoothly. I'm using 16 of the M6 bolts, 15mm length. For the x-axis, the plate moves really smoothly, no problem at all. Now I'm just going to fit this setup on these bearing blocks. I forgot to mention one thing. On this plate of the x-axis, I have to pound in here 2 of the M6 nuts in the slot. So later on I can use them to fix the end bearing blocks to support the ball screws. These 2 plates are tightened and the setup moving back and forth really smoothly, so I can start replacing the brackets at the corners. I'm just going to take this piece of wood, lift this up. So now I can loosen this bracket. I will do exactly the same for the 2 brackets at the back. I was done replacing all the corner brackets for the frame and also installed the ball screw on the x-axis, but I didn't realize that my camera was off, so I was just talking to myself. My intention was that I only show you how I install it on the x-axis and you only need to do the same on the y-axis, but now I wouldn't have to reverse my plan. Just I will show you how I do it on the y-axis and you will do the same for the x-axis. But before doing that, I'm just going to show you very quickly how smoothly the x-axis moves. I'm just going to use the drill, attach it to one end of the ball screw and move it very quickly. As you can see that it moves really smoothly with the drill and you can turn it very easily with your fingers. So now I'm just going to show you very quickly how I do it on the y-axis. You will need one setup of the long ball screw, one spacer like this, and the reason just I want to use the spacer because the bolt here is kind of stick out from this surface. The bolt's head here will push against this plate and this is not going to lay flat against this plate. So that's why you need the spacer. So you just put the spacer at the back here. Use some of the M5 30mm length. Now just slide the ball screw to the back of the plate. Now you can fix the plate and the ball screw set up together. Don't tighten this just yet. You just need to roll this side really close to this plate. And push the whole setup to the back. Now you can fix the end bearing block to the corner bracket. I will use 2 of the M6 ball 40mm length. Once you tighten those 4 bolts, you can loosen those bolts a little bit to adjust the position of the end bearing block. Now you're done with this end, you will have to install this bearing block on the other end. You just slide this bearing block on here, put one of this bracket on top of this one. I got a little problem here. When I designed this bracket, I designed them for aluminum, but now for wood I made it 6mm, but I didn't pay attention that this side of the hole was blocked by this rail, so I cannot put the nuts on this side. So now for this bearing blocks, I think that I only use 1 bracket at the bottom to fix it. I don't think that it will affect that much. It only need to be here to have extra support to the end of the ball screw. So it's not really a big deal if I only have 1 bracket. I just put the bracket down here, slide M6 ball 25mm length through here. Don't tighten it just yet. Just leave it a bit loose and take another bolt just a bit short and slide it through here and tighten the 2 pieces together. Now you can tighten this bolt underneath. I think that it wouldn't be sturdy enough with just one bracket, but later on when I make this corner bracket out of aluminum, I will use two brackets, so that will be extra sturdy. Now I'm just going to try to move it back and forth with the drill. You can move back and forth no problem, so I'm just going to install the bolt screw on the other side. Now I have the bolt screw installed on the X and Y axis. I can tell you just I cannot feel any gap like pushing it back and forth like this. One thing that might induce some imprecision when cutting something hard like aluminum or steel are those two plates here. They are made of MDF, so they might flex a little bit with the force of milling. But I hope that problem will be solved when I replace them with aluminum plates. Next step, I will install the rails on the back of the Z-axis block. Before tightening the rails, I'm going to install some stopper on the bottom first. And the holes on the bottom and top of the Z-axis back block, I already thread them with M6 thread. Next step, I'm just going to slide the bearing blocks on here. Now I will fix the gantry plate of the Z-axis block on here, so I can move it up and down and test the rails, and then I can tighten the rail. I tightened everything and it's moved really smoothly, as you can see. Now I will install the bolt screw on the Z-axis block. I prepared two short pieces of aluminum extrusion 3030 series. You can also use 2020 series. I got the pieces from the leftover after building this machine. So I cut the leftover in half and I have each piece about 8 cm. Now I just take the bolt screw setup. This spacer, I made this piece of spacer 1/4 of an inch thick, so about 6.3 mm. So just slide it to the back. And use some of the M5 bolt 15 to 20 mm length. Next, you just slide two of the M5 bolts through the slot here and put on the T-nuts on it. Now you can fix the piece of aluminum extrusion to the back of this block. Now you just take this piece, slide two of the M5 bolts through these two slots and put the T-nuts on this side, and then you can fix it on this piece of aluminum extrusion. You just let these two bolts a bit loose for now. Now at the front, you just turn this bolt screw so the end bearing block like go up until we touch this plate. And then you can try to adjust the position of the hole here to match the hole on the bearing block and fix them together using two of the M6 bolts. Now you can move this up and tighten the two bolts at the back. And then tighten these two bolts. So now it's really sturdy and you can turn this very easily with your hand to move this up. Once this side is fixed, you can install an end bearing block on this side. Just slide it up here and push this plate all the way down here until it press against this plate, and then fix them together using some of the M6 bolt. Now you can tighten these two bolts to fix this bearing block on the bracket. Now you have really sturdy Z-axis block. Next step, I'm just going to take the spindle clamp and mount it on this plate. I made 6 holes on this plate, but I will only use 4, these 2 and these 2. So I just put the spindle clamp on here and use some of the M6 bolt. Not too long, around 20 or 25 millimeter. You only want it to be long enough to bite into this plate, but not go all the way through. I think that 25 millimeter length with 2 washers here will be just enough. This end of the bolt barely reach this surface. Now we can fix this setup on this gantry plate. And I did the same as before. I have the 3 slots here so I can adjust the angle of the spindle. I forgot to mention that all the holes on these 2 plates, I thread them with the M6 tab. Next step is very simple. I only need to mount all the stepper motor on this machine and it's going to be ready to run again. This is motor mount for the Z-axis, but before I install this on the machine, I will need to install this piece of aluminum extrusion on the back of the Z-axis block first. I will do the same as I did before for this plate. Now just take the stepper motor for the Z-axis block and install it on this plate. Now just take 2 of the M5 bolts, just slide it up here like this and put 2 of the T-nuts on the bolt. Now I will install the spindle and the stepper motor on the Z-axis. You can adjust the position of the spindle later. Now just slide the stepper motor on here. Adjust the position of these 2 bolts so they can slide in the slot of the aluminum extrusion. The Z-axis is done. And I am very excited to see how it moves, so I'm just going to turn on the machine and test it. Smooth, so I will continue to install the stepper motor on the X and Y axis. For the X axis, I will install the coupler on the Ballscrew first. I will need 4 of the M6 bolts, very long. I don't know how long I will need, so I just use 100 millimeter length. That way I will have more room to adjust the position of the stepper motor. I just slide them through the holes here from the other side. Then I can tighten all the bolts to the plate. This is the stepper motor mount for the X-axis. This side will be shorter, so it goes to the back of the machine. But I will have to install the stepper motor on here first. As you can see that I have a distance here. I will fill the gap with some of the M8 nuts, 4 on each bolt. So I'm just going to tighten this setup to the plate using some of the M6 nuts. Here are the motor mounts plate for the y-axis. As you can see that they are not symmetrical. This slot are a bit closer to the edge and those two are a bit further. So the further slot will face outward like this to the edge of the machine. I will start by fixing the stepper motor on the plate. I will do the same thing as I did on the x-axis. That is for the long M6 bolt. This happened again. I didn't pay attention that I was designing the bracket for aluminum pieces. So this hole will be threaded with the M6 thread. But now because it's made out of MDF, I need to slide the bolt through. But it got blocked by this rail. So I will have to skip this hole. Again, I will need some of the M8 nuts as spacer. That's it. I will do the same for the other side. And then I will test the whole setup again. It ran really smoothly. I love the sound of this. I will need to do some tuning for the stepper motors, but everything seemed to work really well. I forgot to install this tool stopper on top of the rail on the Z-axis block. I rearranged all the wire and tubing, so now the machine is ready to mill again. My next step is to replace all the MDF pieces with aluminum pieces. I will mill them out using some of the 1/2 inch thick aluminum plate. So the brackets will be very sturdy, but it will take longer to mill and also very hard to cut it out using the CNC machine. I will try again with the 2D contour. That will save some more time. But if I keep doing the same thing as before, the bit will get stuck and break again. So what I will try to do is to use some water as coolant and spray it to the bit. Hopefully the aluminum not going to heat up and get stuck to the bit. That way I can cut the piece out using 2D contour. So let's see how it works. For the second tool path, I use 6mm single flute flat end mill. I don't know if you noticed, but I turned off the water scene almost the beginning because it was really messy. I hope that you can appreciate the finish on the side here. It's almost like a mirror and you cannot really see the line between the layers. It's cut really like precisely. So I'm really happy with this. Next step, I just going to use the smaller bit to cut this piece out. Cutting the piece out using the 2D contour this way, it will make the piece look a lot better, more professional. That's it, the piece was cut correctly. It took me about 1 hour 20 minutes to cut this piece out, but it is half of an inch thick, so about 13 millimeter. I think that 1 hour 20 minutes for this piece is more than acceptable. Now I will continue to cut all the brackets and plates, but the video is getting very long already, so I will show you the rest in the next video. Let me just summarize quickly what I learned about aluminum milling with this machine. First of all, if you are using this type of spindle that has really high speed, the maximum speed on this spindle is 24,000 RPM. I use it at 18,000 or 20,000 RPM. And just to be safe, to cut aluminum you should use single flute end mill like this. I tried other bits with 2 or 4 flutes. The chip just got stuck on the bit and break it. So single flute end mill is the way to go. And the bits that I am using here are not really expensive. The small bit, 1/8 of an inch diameter, I bought 10 of those for $15. And this 6mm bit costs $5 per bit, so they are really cheap and they cut really smoothly. As you can see, you almost have the mirror effect on the side here. Second thing is the vibration. The first source came from the wood brackets that I made from MDF. They flex a lot and create a lot of vibration. And the second source was the Leadscrews. They have the gap that's moving back and forth and created also a lot of vibration. All of that put together make the bit like hit against the material when cutting, and that actually will break a lot of bits. So if you want to save your bit, you better upgrade your Leadscrew to Ballscrew and also all the bracket to aluminum or steel, so the machine won't vibrate anymore and the cut will be smooth and it will save a lot of bits. And the third thing that I learned is that the chip clearance is really important. That's why I had to blast some compressed air to the bit. That way it will cool down the bit and also blow the chip away. And I didn't have any problem with the chip getting stuck on the bit and weld to it and break the bit after the long cut of 2D contour. So now I can already imagine how smoothly this machine will cut after I replaced all those corner brackets and those 2 big plates on the x-axis with aluminum plates. Please stick around and watch my next video. I will show a lot more details about my settings to cut aluminum on this